Hi, my name is Jonah Erlebacher, and I'm a professor here in the Department of Materials Science and Engineering. I'm also a member of the Leadership Council of ROSI, the Ralph O'Connor Sustainable Energy Institute here at Johns Hopkins. My background is in physics. I earned my PhD from Harvard University and joined Johns Hopkins in 2000. My work at Hopkins has been quite varied, but there's a common theme. I use fundamental material science principles to tackle some of the world's most challenging problems, from corrosion to fuel cell catalysts to global warming. Most recently, my interests have centered on energy technologies that will lead to large-scale emissions reductions. We do this by decarbonizing fossil fuels using reactors that pull carbon as an elemental solid out of natural gas, leaving only clean-burning hydrogen fuel behind. My interest in hydrogen as central to solving energy emissions has been ongoing for a long time, ever since I was one of the first recipients of a Hydrogen Fuel Cell Initiative grant in 2004. Hydrogen is a simple molecule and produces only water as emissions when it is combusted or used in a fuel cell to produce energy. But pure hydrogen is hard to make. Our methods to extract hydrogen from natural gas without producing carbon dioxide emissions are likely the most efficient and clean way to make this important molecule, and Etch Inc., a startup spun out of my group, is working hard to commercialize our approach. The flip side of this problem is that as we make hydrogen from natural gas, we also make a lot of solid carbon. One important form of carbon is graphite, which is a critical material and a central material in battery technology. We have a completely new, low-temperature way of making graphite from natural gas. This is really an exciting advance and amenable to large-scale manufacture. Another way my group is working to reduce emissions is by decarbonizing cement. Cement makes up about 8% of global carbon dioxide emissions worldwide, so finding creative ways to solve that problem would make a huge difference. We work with so-called reactive magnesia cements, working to produce them not just emissions-free, but in a carbon-negative way. For the nearly 25 years that I've been at Hopkins, the university has been incredibly supportive, facilitating my research, entrepreneurship, and leadership ambitions. I was particularly honored to have led the Department of Materials Science and Engineering as chair during much of the 2010s. I've worked with and continue to work with an amazing group of hardworking scientists and students, and I'm more excited about our research than ever. Thank you.